I almost forgot that I needed to do the directions for graphing a logarithmic function in between these two examples, but I had left space in my document for that. So to graph logarithmic functions, we're going to decide on our basic logarithmic function, which is y equals log base b of just x. And then we're going to convert y equals log base b of x to exponential form. Which is b to the y equals x. And I'm just going to scoot that over. Use it to make your XY chart. We're going to plug in y, which is kind of the opposite of what we normally do. Usually -1, 0, and 1. And get out the x that goes with it. Sketch a mini graph. And decide the shifts your graph is making and draw it in its new spot. And in general, we want to shift the vertical asymptote which was at x equals 0. And the point that was 1, 0. First. Okay, so example C is f of x equals log base 1/6 of x minus 1. And the first thing that we want to decide on is our y equals log base b, which is 1/6 of just regular old x. Once we write him in y equals, then we're going to, if and only if, 1/6 raised to the y is equal to x, base raised to the answer equals the inside. And then we can make our XY chart, but instead of plugging in x's, we're going to plug in y's. And we're going to plug in -1, 0, and 1. And so this is 1/6 to the -1, which is +6. 1/6 to the 0, which is 1. And 1/6 to the first, which is 1/6. And next I want to sketch my mini graph. Now my x does need to go out to 6 this time. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3. -2, 2, 2. 4, 6. Okay, so when we plugged in 6 for x, even though we didn't actually plug him in, but if we had plugged in 6 for x, we would have gotten out -1 for y. 1, 0 is a point on our graph, and 1/6, 1 is a point on our graph. And we get this, picture this time. Our vertical asymptote is still at x equals 0 for now on our mini graph. Okay, so back to my function that I'm actually trying to graph. I am asking myself, okay, what is my -1 doing to my graph? Is -1 inside or outside, and how am I supposed to know? And I just want to draw your attention. Log base 1/6 of x minus 1 is not the same as log base 4 of x minus 1. How did I know that -1 was inside here? I knew that he was inside here because of the parentheses. And the other point that I'm making here is that without the parentheses, he needs to be considered outside. And outside is our up or down move. We do same as the outside, which is why we go down 1. So that means that my vertical asymptote hasn't moved at all. He is still at x equals 0 because I want to graph my vertical asymptote and what was my 1, 0 point first. So my vertical asymptote is x equals 0 still. Now, all of the points that I have here on this graph just need to take an elevator down 1. So it's going to be at 1/6, 0, at 1, -1, and at 6, -2. And I guess I should have done this in a different color, or it probably doesn't matter. Let me try that again. It's supposed to be a curve, not a line. Okay. And this is my graph this time. So, domain, what x values can I hit with this graph? I can get really, really close to my vertical asymptote. I just can't actually hit him, which is why we're going from 0 to positive infinity. We did not hit 0, which is why he gets a parenthesis. Infinities always get a parenthesis. What y values can we hit with this graph? Range of pretty much all of your logarithmic functions should be from -infinity to positive infinity. Just a little reminder, because I feel like I haven't been reminding you lately, don't type positive on your positive infinity into the computer because it will get mad at you. Okay, now I'm going to pause my video, and then next we're going to look at properties of logarithms.